Suppose that the space S contains exactly 8 points. If script S is a collection of 250 distinct subsets of S, which of the following statements must be true? S is an element of script S. The intersection of all of these sets is S. The intersection is a non-empty proper subset of S. Script S has a member that contains exactly one element, or the empty set is an element of S. Okay, so part of the key here is that if the cardinality of S is equal to 8, then the cardinality of the power set, how do I want to write? I'll just write P of S. The total number of subsets of S is equal to 2 to the 8, which is this 256? Yeah. Okay, so once you see that the total number of possible subsets of S is 256, but that the cardinality of the script S is 250, we can start to rule out some of these statements very well. I believe the answer here, I think, is going to be D, that script S has a member that contains exactly one element. But let's rule out the others and argue why. So option A, that S is an element of script S. I mean, just take the entire power set and remove this set S itself. That leaves me with 255 things, and then I can just remove any 5 others. So this does not have to be true. The intersection, B is certainly false. This is definitely false, because certainly at least one of these sets is not S itself. So the intersection cannot be S. In fact, at most one of these sets can be S, and there's 250 of them. So that's wrong. This thing is a non-empty proper subset of S. So that's not necessarily true, because one of the elements G in script S could be the empty set. Nothing stopping that. D, I mean, the reason my instinct immediately went to D once I wrote this out, I think it's just a pigeonhole principle thing, right? There are 8 sets that have exactly one element, right? If the cardinality of S is 8, there's exactly 8 sets that have exactly one element. And so in going from 256 down to 250, you can't possibly remove all 8 of those. At most, you can remove 6 of them. So in fact, there are at least 2 sets in S that have exactly one element. So that's the argument for why D is correct. But E, the empty set is an element of S. No. For a similar reason that S is an element of S, the empty set does not have to be an element of S, because just take the entire power set, remove the null set, and remove any 5 other sets. Then this is not true. Yeah. So the answer is D. You can eliminate them one at a time, but if you write down these cardinalities this came to me, the instinct came to me right away that, is it a pigeonhole principle type thing? Not, maybe, I don't know. You're just counting. There are 8 sets that have exactly 1 element, and you cannot remove all 8 of them in going from 256 down to 250. Yeah, if I have more to say about this one, I'll put it down in the description. Thanks for watching.